Dear students, welcome to this class. Our topic is transformation by using matrix. This is the first day. So we'll start from the some basic concept of this chapter. So let's go ahead. So you can see here the main types of problem of this lesson. So I have categorized into two categories. One is under basic skills. So mainly two important skills you are going to learn in this lesson. One is to find the matrix associated with given transformations. We are already familiar with different type of transformation and combined transformations. So we know its formula in terms of coordinates, how the image will form. But in this chapter, if we know the transformation, then we can find its matrix form, because the matrix can be equivalent to the different types of transformation. So that is one of the skill. So we'll find the matrix associated with given transformation. Second thing, it's just a reverse process, means if the matrix is given, then we will find its equivalent transformation. So this thing will be more clear when we start solving problem. And while solving long question, normally there are two categories. One is we'll find the coordinates of the vertices of the images by using the matrix method, not by using that for coordinates formula, but by using matrix method. That is one very important type of long question. And the next one is if object and images are given, that time we'll try to find what is the transformation matrix. So let's go ahead for some other portions. Okay, now here I'm going to talk about formula. Especially there is only two formula used for this chapter. One is I equals to mo, another is I equals to m plus o. I equals to mo means where the symbol have their usual meaning. I means image, m means matrix, transformation matrix, and o stands for object in both cases. But normally I equals to m plus o, it has very rare use, and here is written the note also. This is applicable in case of translation only. In case of translation only, this formula I equals to m plus o is useful, but in other cases like reflection, rotation, and enlargement, we'll use I equals to m times o. So here what we have to understand, image also will write in the matrix form. M itself is a matrix that is called transformation matrix, and O stands for object, and these all three elements are in matrix form. So besides knowing all those coordinates formula of the formation of images, you have to learn these two formula, I equals to mo and I equals to m plus o. So let me go ahead. Now we'll go now in one problem solving part. Okay, now here in a detail we are going to solve one problem, that is what is the heading? To find the matrix associated with given transformation, one of the basic skill. And here is one sample question. Find the transformation matrix associated with reflection on x-axis. So in this case, based on, because a transformation is given, what is the transformation? Reflection on x-axis. But what we need to do, we need to find a transformation matrix that represents reflection on x-axis. So it is one of the application of matrix. Actually, matrix can be useful in different field. Like in matrix chapters, you learn use of matrix while solving equation also. Now here is use of matrix in the transformation also you are going to observe. So at first, let's write a coordinates formula, how the coordinates will change when object x comma y reflect on x-axis. So I think you know the formula is x comma minus y. So x comma minus y is image, and x comma y is an object. Now with this relation here, we are going to find what is the matrix that represents reflection on x-axis. So what is that transformation matrix? We are going to find. So I'm explaining very slowly here, so that the basic thing you'll get information from this single problem, and you have to take the reference of this problem to solve some other question. So here, one of the main thing is when you see the image, there is x coordinate and y coordinate. So the x coordinate is x here. So one of the interesting thing is you need to extend that x, means you need to write x in expansion form, or we better to say we need to write x into the linear form, means introducing x and y together we will try to expand. So one question for you, here you can see only x. So what about coefficient of x? What value is existing in front of x there? Can you guess? It is not visible, but from our common understanding we know that the coefficient of x is 1. There is this 1 is existing in front of x. So we will write 1 into x. It is equal, but one more thing is here. To find the matrix we need to introduce here y also, but there is only x, single x is there, but how can we write y also since y is missing? So in this case we will write the coefficient of y equals to 0, so we'll write 0 into y. In this way, what is the rule? You need to keep x first, you need to keep y second, and with the coefficient you have to expand. In this case, second case, there is minus y, and just in front of y as a coefficient, what is the coefficient of y? That is minus 1. Now how can we expand like above process? Here x is missing, there is no x, so x is missing, so we write 0 into x, and there is existing y only, so the coefficient of y is minus 1, so minus 1 into y. So this is the main thing you have to understand here. So when you see the formation of image, you simply try to extend those x coordinate and y coordinate by the same rule. If there any term is missing, then keep that coefficient 0, means any term means simply there are two terms, x variable and y variable, so you need to keep the coefficient of x variable and y variable. If x is missing, then its coefficient is 0. If y is missing, and its coefficient is what? 0. Now let's start this problem. So here we'll start from the image. So let me write image. The notation used for image is capital I, so I stands for image, so I'll write I, and then I equals to, I'll write that coordinates x comma minus y in matrix form. It's image in matrix form. Let's write in matrix form. Now it is a matrix, it is column matrix. Now just now what we are discussing, we need to expand x part also, we need to expand y part also, means how can we expand x? So simply just now we discussed 1 into x, because coefficient of x is 1, but there y is missing, that's why coefficient of y is 0. Let me use this eraser here. So what we are talking here, coefficient of x is 1, but there is only x as a first element, but you need to write y also, but y is not there. So in this case, since y is not there, so you need to keep coefficient of y 0, then you can write 0 into y. So this simple thing, please try to learn. How can we expand the first element of the matrix and the second element of the matrix? Same case, now in second case, you need to expand minus y, but first you must write x. In case of minus y, there is only minus y, so where is there is no any x, isn't it? There is no any x, so in this case you need to keep 0 into x, because there is no x, there is only minus y, x is missing, and for y its coefficient is minus 1, that's why we'll write minus 1 into y. Yes, in this way we'll do expansion. So we did expansion. Now one interesting thing is this is a single matrix now, but we can decompose this matrix into two matrices, so that is very interesting, and I'll try to make it clear also how can we decompose. or why we can decompose. You have to decompose into two matrices. One is matrix of coefficient 1 0 0 minus 1. Exactly, simply take the coefficient only from the above system and form one matrix, and one separate matrix is just the matrix of the variable. So in this way you can decompose two matrices in the form of product from the above matrix. This is very interesting. Now the question mark is, how can we do this? So for this, to answer this question, let me explain here separately as a rough. So what we are going to explain now, discuss this 1 into x plus 0 into y and 0 into x minus 1 into y, that single matrix, how can we decompose into two separate matrices? What is the logic? Are they equal? Of course they must be equal. So here let's multiply these two matrices because they are in product form. So what is matrix multiplication? Multiplication between this first row and first column, you can see. So 1 multiply with x, first element with first element, one multiplication between corresponding element. So 1 into x. Now it's time to multiply 0 with y. So there is no negative sign, so we'll write here plus 0 into y. 0 into y. Yes. Now similarly, we multiply first row with first column. Now multiply second row with first column. So when we multiply second row with first column, then 0 into x, we'll write 0 into x. And similarly, we'll write minus 1 into y. Minus 1 into y. So 1 into x. So now simply multiplied, and what is our result? The result is the first one matrix. See, you can see. So 1 into x plus 0 into y and 0 into x minus 1 into y, the single matrix can decompose into two matrices in the form of product, because when we multiply we'll get the initial one, when we decompose we'll get this second step matrices. So please be convinced. So till now what we are discussing, we started our problem from the image. We wrote coordinates in the matrix form. Then the very special thing is we need to expand the first element of the matrix and second element of the matrix in terms of x and y. If any variable is missing, that time its coefficient is 0, and you must write those expansion form also in order. Always x comes first and y comes second, and then after that you can decompose into two matrices. From there you will get one coefficient matrix and another is variable. Now till now we are discussing some basic thing. Now let's solve this problem again. So image I equals to x minus y. Yeah, this is okay. Now here we can do the expansion. Just now we talk a lot about this. 1 into x, in first element there is no y, so coefficient of y we keep ourselves 0, because 0 into y means nothing. Now for the second element there is minus y only, so we cannot write minus 1 into y first, because first we need to give turn for x come first then y. Simply same slogan we used to use in matrix also. So there is x is not there, so 0 into x, but for minus y the coefficient of y is minus 1, that's why minus 1 into y. So we did expansion of this first matrix in the form of image. Now we are going to do its decomposition into two matrices. One matrix will form from the coefficient, so 1 0 0 1. Exactly, simply take those coefficient and construct one matrix from the coefficient, and another matrix is from the variable x and y. Now see the conditions here. So we started our problem from image I, and we are getting two matrices. So IE stands for that is the short form of that is used for mathematics. So in the starting I introduced one formula, that is I equals to M times O. M times O. I stands for image, M stands for matrix, and O stands for object. So in that above also we have mentioned which one is object and which one is image. So when you are comparing with corresponding matrices, so what you understand here, I is x comma minus y, O is x comma y. Now that new one matrix constructed from the coefficient, that is M, that is called transformation matrix, which is equivalent to the reflection on x-axis. So the final answer is required matrix M equals to 1 0 0 minus 1, 1 0 0 minus 1. That is our required answer. So similarly we can go, I'll do here some problem very fast. I want to teach some problem of rotations, so let me go fast. So let's talk about this question. Find the transformation matrix associated with rotation through plus 90 degree about origin. So first you state those formula of rotation plus 90 about origin minus y comma x. Now many things we talk in detail, so simply very briefly we are going here. So image you have to write in matrix format first, minus y x, and then after that minus y you need to do expansion, but you cannot write minus y at first. X comes first, but in the first element there is minus y only, there is no x is missing, so 0 into x. And while writing y, of course coefficient of y is minus 1 because it is minus y, so minus 1 into y. By the same process we'll expand x, there is 1x, so 1 into x, but y is missing, so 0 into y. In this way, this is the very vital step. After that we'll decompose this. We'll decompose this now into two matrices. One is matrix of coefficient, another is matrix of variable. Yes, matrix of variable. So now simply that is we are comparing this process with one of the formula, that is I equals to MO. I equals to MO. Okay. Then from here when we compare, then you can see a 2 by 2 matrix, that is the transformation matrix, which is the required matrix M 0 minus 1. So similar process for almost all questions if you need to calculate a transformation matrix. Now let me share next one video for some other different question. Okay, in this question, let me go fast here. We are solving a problem of enlargement. Look at this question. So find the transformation matrix which represents enlargement by E 0 comma 0 comma k. What is this means? It is the enlargement about origin with scale factor k. So you have to state the formula. You know, you are already familiar with this formula. Now from this formula I have taken only image part, that is kx ky, and written in the matrix form. Now by the same process there is no any confusion, there is k into x. Kx means k into x. So k into x. What about y? In the first element there is no y, that's why 0 into y, because y is missing. Now similarly, let's do the second case. Second element, there is no x, there is only ky, so 0 into x, and there is ky, so k into y. So it is similar. In this way you can form another matrix, single matrix, and it's time to decompose. Let's decompose. Now it is k 0 0 k. So normally you have to understand, if you did the transformation related to the enlargement about the center at origin, then you will see always this type of 2 by 2 matrix. And k is a scale factor. If in place of k, if there is 2, then it looks like 2 0 0 2, something like that. Now same process, that is, we are comparing this process with one of the formula I equals to mo matrix into object. So I is there. What is matrix I? That is kx ky. What is matrix object? That is xy. So what is m then? K0 0 k. So required matrix m is K0 0 k. So there is some other varieties of question I would like to introduce. Let's talk about this question. In this question, what is the interesting thing here? No need to remember the formula. A formula is given itself. You need to find the transformation matrix based on these relations that represents these relations. Here is one formula. Till now we are talking, we have written ourselves the formula of reflection on x-axis, or rotation through plus 90 degree about origin, or enlargement by scale factor k about origin. But here no need to remember a formula. In the question the formula is given. So x comma y is an object, 2x plus y, 3x minus y is image. In this situation actually it is easier than the first one, because here no need to remember the formula. So now the image part, 2x plus y, 3x minus y, let's write in matrix form like this. Yeah, let's write in matrix form. We'll write in matrix form. Now here no need to keep a 0, because here x also existing and y also existing in first element as well as second element. So exactly you have to write its coefficient. So here you can use that blue ink I have used. 2 is the coefficient of x, 1 is the coefficient of y for the first element, 3 is the coefficient of x, and minus 1 is the coefficient of y for the second element. So simply visualize those coefficient one time. Here we are not writing 0 into x, 0 into y, because x also exists, y also exists here. Simply we are writing 2x plus y means 2x, 2 into x plus 1 into y. 3x minus y means 3 into x minus 1 into y. Yes, 1 into y. So here what is different? Here we are not writing in 0 into x or 0 into y, because is x and y both are not missing for both element. Now let's decompose. Other thing is same. From the coefficient you can write one matrix, that is the matrix of order 2 by 2, and from the variable you can write another matrix, that is x and y. Yes, in this way you can write. Now same case, till now we are talking only one formula, that is I equals to mo. So that is I, that means image matrix, equals to m, that is 2 by 2 matrix, that is also called transformation matrix, and O is object matrix. And when you compare the 2 by 2 matrix, which is visualized here, that is the required matrix M. So what is required matrix? 2 1 3 minus 1. Yes, minus 1. This is the required 2 by 2 matrix. So this is another varieties of question. So till now we are talking about how can we find the transformation matrix M in different cases. Now look at this exceptional case, means a unique case, let's say a rare case. In this case there is a formula, x comma y is an object, then x minus 1 comma y plus 2, this is an image. So let's write image in matrix form at first. But slightly this last question is unique. Then other question, why? You may think why it is unique. Because in this question, what do you think, that given relation, that is related to which type of transformation? It is reflection, rotation, or translation, or enlargement. Can you try to remember those formula? It is relevant to which formula? It is relevant to x plus a comma y plus b, and that is the formula relevant to represented by the translation vector t equals to a b. So that's why this is the problem to represent translation. So in case of translation, the transformation matrix is of order 2 by 1. It is not of order 2 by 2. Only in case of translation. So that's why it is very easy here. We are not going to multiply two matrices. We are not going to decompose two matrices just like in first case. Here we are going to decompose two matrices in the form of sum, because it is from the translation. That given formula define translation, that's why. So x minus 1 and y plus 2, it is quite clear. We can decompose like this. Okay, let me go ahead. Here is something I need to erase. Okay, dear students, now we are going to discuss further. Okay, so I wrote image in matrix form and I decompose, but not in the form of product but in the form of sum. Now that is, if you remember in starting I have shared one formula, that is I equals to m plus o. That m plus o is simply I equals to m plus o. There are only two formula. One is I equals to mo, m into o, and there is I equals to m plus o. So m plus o. Now you need to compare here. O means x comma y. You can see in the starting also x comma y is an object. So what is the required 2 by 1 matrix? So required 2 by 1 matrix is minus 1 and 2. So thank you so much for today's homework. This video is very much useful. So please don't forget to watch this video. Take care. Have a good time.